Hi, my name is Juan Manuel Parrilla and I want to show you what kind of project is CTP Factory Workflow. CTP Factory Workflow is basically a bare metal enclosure that the factory of a manufacturer will prepare for the final customer with an embedded OpenShift in a CTP pipeline. CTP stands for Zero Touch Provisioning. This pipeline is basically separated in two parts. The first one will ensure that your hub cluster contains the proper elements to deploy some edge clusters. The second part is the edge cluster deployment itself. So let's get started with a bit of context. In order to introduce you in a CTP factory workflow context, we need to look at this logical diagram. In the factory side, we need to prepare some prerequisites. OpenShift cluster deploy that we will use as a hub cluster, some persistent volume already set on this hub cluster. DNS configuration to reach the API and the ingress of the hub cluster, and also one of these two entries for every edge cluster we will deploy. Enough DHCP addresses to host how many edge cluster we want to deploy, and an NTP ready to be seen between all of the clusters deployed on the factory. First thing we will do is basically check the status of the hub cluster and ensure all the needed components are present. We need to check the nodes, cluster operator, cluster version, and also if there are enough PVs to work with the CTP factory workflow. Another thing you need to prepare is the spokes.yaml file, which is the definition of the CTP configuration plus the edge cluster node definition where we will set the versions of OpenShift, ACM, and OCS. In this part of the workflow, we only care about the config section, so the spokes part, it's okay to be empty for now. To start the bootstrap process of CTP factory workflow, we will need to execute this bash script you see in the screen. This process will clone the CTP factory workflow repository, download the necessary binaries in case you don't have them present on your machine, create the proper permissions on the hub cluster to execute the necessary commands to complete the pipeline flow, deploy the OpenShift pipelines operator from OLM catalog, and deploy the tasks and pipelines associated with the CTP flow. This bootstrap script execution can be done as many times as you want. No worries about re-execute it if you see any failure. As you see on the right side, you will have the pipeline section on the OpenShift console, so you can control the execution via browser or CLI. Among the permissions create, we also add a new namespace called Spoke Deployer, where we will store all the artifacts for OpenShift pipelines. So ensure you are set on that project when you are looking at the OpenShift console. Okay, in this session we will cover the hub pipeline execution, all done via CLI. As you can see in the screen, the command has multiple arguments, so let's explain any of them. The first one is take an pipeline start, which is the action we want to execute over the hub cluster, and with a -n, which involves the namespace where it will be executed. Then we need to pass our edge cluster file to the CTP factory workflow pipelines, so we need to execute a cat command over it. Now we will use the path location of our kubeconfig using it as a parameter. Then we will set our pipelines workspace as CTP. Meanwhile, we will use a previously created PVC called CTP PVC. The two last arguments are basically a timeout, and the other tells the pipeline parameter as a default ones. We will follow this way of execution in the right side. We will have the console open, and in the left side we will have the log execution of the whole pipeline. So this way you can check the pipeline statuses and also check the ongoing actions. I will talk about the different stages of this pipeline execution during this fast forward. First stage will execute some preliminary checks over the binaries and also over the hub cluster. The second one will deploy an HTTPD server, exposing it as a route. Then the code will download all the Red Hat CoreOS ISOs, and these ISOs will be used by assisted installer during the edge cluster deployment. The next step is the most time consuming of the pipeline. It will deploy a container registry, and also it will handle the OpenShift and OLM container image synchronization. After that, the pipeline will deploy ACM operator and the multi-cluster hub OpenShift object, which will provision the whole Red Hat ACM product. Then it will apply the image content source policy and a catalog source that will point to our own registry instead of internet in order to work in disconnected mode. The last step, it will be the assisted installer pod creation, which will be the component to deploy the edge clusters. Okay, now that the hub pipeline has finished, we will perform some checks to validate that all is fine. Okay, now that the hub pipeline has finished, we will perform some checks to validate that all is working fine. And to finish the demo, you can take a look over the pipeline run using the CLI command. You can check how much time the pipeline has consumed, the parameters submitted to that pipeline, or if there are any issues with any of the tasks executed.